Hooked on hip-hop-phonics. Yeah, it works for me, so jump aboard. Yeah, this train is free, the conductor.
What's up, guys? Welcome to another video brought to you by The Simple Engineer. And today we are going to be covering a really exciting topic, and the topic is the factory design pattern. Now, in software development, there are basically a ton of different patterns that you can use. Now, the problem is people write code, right? Kind of procedurally top down. They write a bunch of methods and functions and classes, and the code works, right? But then down the line, maybe their product owner, somebody tells them that they need to make a change. And now all of a sudden, because there's been all this class dependency within their code, things have broken, and they make one change in one place, and it doesn't necessarily sync up with all of the other places that they wrote that same exact code, because there's code duplication and really just inconsistencies with the way that they're writing their code and instantiating classes. So today we present the factory design pattern, and there's kind of this jargon-filled definition by the Gang of Four, which are the original four authors of the classic design patterns, Elements of Reusable Object-Oriented Software book, and they essentially define the factory design pattern as an interface for creating an object in which you let the subclasses decide which class to instantiate. And then the factory method allows you to basically defer class instantiation to their respective subclasses. Now, if you were like me, the first time that you heard that or read that, it may have not had made any sense whatsoever, but that's what this video will hopefully help resolve. And we'll dive into some code examples, some pros and cons, and some actual kind of high-level drawings to better understand the idea using kind of a realistic, contrived example. Okay, so without further ado, let's dive into a quick overview. So the example that I've come up with that will hopefully get the idea across is we work at a software company, right? And we are site reliability engineers. Now, within our job, we have several servers. We have FTP servers, we have mail servers, we have app servers, and we have, let's just say, test servers, right? Now, we have a nice application that's been developed that anytime one of these servers goes down, we can select from a drop-down, basically just resolve the issue. And what it does is it goes through a bunch of different server-specific algorithms to resolve the issue. So, you know, if the FTP server goes down, we can select FTP and basically just resolve it, and it'll run through a bunch of computations and algorithms, and then everything will be fine and dandy. And that's kind of the dreamlike application that we will develop today using the factory method. Is we kind of have this main class here, and this will be the main entry point of our program, and we'll just call it server. This is a class, and it has a main, and the idea is we just want to basically create an object. It'll be called like server ... It'll just be a server object, and we want to call server.resolve. And the resolve method can dynamically resolve either the FTP, mail, app server, or test server totally independently of this class whatsoever. We just type in, say, a string that's like FTP, and when we call resolve on this object, it will load in the FTP object for us and then call the FTP specific resolution algorithm. And if that doesn't make sense, hopefully it will in the code. But the idea is that we have this kind of main client core component of our application. There's no business logic whatsoever. But then we have a factory, and this will be basically a server factory. Now, when you think of a factory, you think of basically a large building that produces a bunch of something, right? So an iPhone factory produces a bunch of iPhones, and that's exactly what this does, right? We have a server factory, and what it does is it produces a bunch of servers for us that we're going to manage. And like I said, we have mail servers that we want to manage. We have FTP servers. Basically, all of these ones that we've listed above, we instantiate these. And in the server factory, what happens is we take some specification criteria that helps us define which instantiation of these subclasses we want to actually return to our client code. That's the idea, right? So if we passed in this FTP string, we could go through some case statements to basically instantiate a new FTP object. And now this is where polymorphism will come into play, and I won't dive too deep into that until we start coding it, but ideally we have a bunch of these kind of subclasses, and these subclasses run the specific algorithm. So we have a resolve algorithm in each of these, right? Resolve, resolve, resolve. And anytime that we call the server.resolve function in our main client application, it goes through, it figures out, okay, this is the object that we wanted, and then it calls this specific resolution algorithm from that object. It's pretty cool, and it's all nicely organized into this kind of categorical hierarchy. It all gets returned using polymorphism, and maybe we'll do abstraction here. We don't necessarily have to, and then we'll have like an interface here. This will just be an interface with a resolve method that each of these will implement. And this kind of defines a binding contract for all the servers that we're managing. So let's go ahead and dive into a little bit of code to better illustrate this example. So using IntelliJ here, we're going to create a new class, and we will just call this the server management tool. Now, the main purpose of this class, like I said, is somebody opens up maybe a GUI and they select which server they want to resolve because the site reliability engineer has realized that a server has gone down. So they want to be able to resolve that specific server. So we'll go in here, we'll say public static void main, string args, and we can't fill this up too much because we haven't written a lot of code, but let's go ahead and basically get some user input. So we'll say scanner input equals new scanner system.in, and go ahead and import this. And now we want to basically ask the user, since this is a very, very simple console application, we'll ask the user what type of server they want to restart. So we'll say system.out.println, which server do you want to resolve? And we can just simply say string server results equals input.nextLine. And now we have that server stored in a variable. Very simple. Totally has nothing to do with the factory pattern. Just want to really illustrate the benefits of doing something like this. Okay, so now we want to define the factory. Right, so like I said, the factory will pump out a bunch of different servers, and this is kind of where we're going to manage all of our servers. So just from a hierarchical standpoint, I'm going to create a new package that will just manage this. So we'll call this package server management. And within this server management package, I'm going to create the factory. So we'll just call it, it's just a regular Java class, we'll call it server factory. And just like I said before, the purpose of this is to pump out different types of server objects, or any object that manages a specific server. So what we want to do is we want to make sure that in this server factory we can get an instantiation of one of our server objects dynamically based on some user input. So I'm going to define a static method called public static, and it will return a server object, which we haven't built yet, but we will. and it'll just say get server. Now, when we get the server, we'll pass in the server type that we want. So I'll just say string server type. And this is where we will implement basically the case statements for determining which server we want to give to the user. So first thing we want to do is instantiate a server interface. So we'll go in here and we'll say Java class interface, and we will call it server. And we'll actually just call it iServer just to keep it simple here. So for iServer, this is where polymorphism will really be useful, because all we do in here is we say anything that implements this iServer interface will need to utilize the method of the resolve algorithm. Now, the resolve algorithm basically resolves any network related issues for a specific server. That's the basically underlying reason for having a method like this. So now if we go back here, we can, this is going to be called iServer. So we're going to be returning this iServer type from this function. And this is very handy for the following reason. So in our server management package, we're going to define some of the servers that we actually own. So like I said before, we have a mail server. And what we want to do in each of these is we want to implement or inherit the iServer interface. Now, the reason we want to do this is because now we have a mail server class that is also of the iServer type, which is where polymorphism comes into play. So it is a mail server, but it also is an iServer. So this kind of dual citizenship that it can take as a server makes it polymorphic in nature. So we can come in here and we can say, okay, system.out.println performing some complex mail class will do. So that's what the mail server will do. We'll do the same thing for, let's say, FTP server, and the FTP server will also implement the iServer class. And we can go ahead and copy and paste this line over here and change this to FTP server. And that's all we'll do for now, and we can illustrate how this is flexible in the future once we finish the actual factory implementation. Okay, so quick recap of what we've done so far. So we have a server factory. The idea of this factory is it can dynamically return a server type based on the user input. So that's the next step. We've defined a couple servers with some resolution algorithms. So for a mail server, anytime a mail server goes down, we want to be able to call this resolve algorithm to help fix it. And then, come in here and we can say, and same thing goes for the FTP server. We've defined an FTP server. Okay, the FTP server has been fixed once we call this method on this object. Now, the benefit of implementing an iServer is that when we return an object type, we can return an iServer. We don't have to specify that it has to be of a mail server type and make a bunch of different methods for getting mail servers or getting FTP servers. We can do it in just one method, one static method. So we don't even need to instantiate the server factory class. So we can just come in here, we say iServer, and the user has told us which server they want to restart. So we come in here, we do a basic switch statement. So we switch on the server type. And we'll say, okay, if they say they want to restart the mail server, then we will return a new mail server object, right? Now, if they say that they want to restart an FTP server, then we can return a new FTP server object. And we're actually returning here, so we don't need a break statement. And then, for now, we can just have a default and say throws new exception, invalid server type. And then we'll come up here and just say throws exception. And there we go. So this is literally it. This is what a factory does. It takes in some specification criteria, and it instantiates a new object for you based on the user input. So going back into the server management tool, this is basically, we've asked the user what type of server does the user want to resolve. And then we come down here and we can say, okay, well, we want some generic server. We don't know what yet. This is how we kind of keep it dynamic at runtime. And we say server equals, and we can call the factory to get the server that we want. And we can just call server factory dot get server, and we can pass in whatever the user typed in. And of course, we need to throw an exception. And there we go. So right now, we haven't specified if we want an FTP server. We haven't specified if we want a mail server. We haven't done that here. But this code is smart enough to determine, based on the user input, which type of object it's going to build for us in the factory and then produce for us at the end of the day. So now we would come in here and say server.resolve, and this would run the specific resolution algorithm that we've defined based on the type of object that we've built. So let's go ahead and run this. So we run our server management tool, and it says, which server do you want to resolve? Well, let's go ahead and resolve the FTP server, because we see that the FTP server has gone down. Okay, so what we see is we are performing some complex FTP server resolution algorithm. So whatever that does, maybe it changes a bunch of settings for us and then reboots the machine. And we can see that the FTP server has been fixed. And we have no specification for FTP here whatsoever. We've abstracted all of that logic from the core client code, which is super beneficial. So without changing any code here, I can rerun the same thing, and I can type in, okay, which server do we want to resolve? Well, maybe I want to resolve the mail server because our email system's not working. Oh, and then it says performing some complex mail server, and then all of a sudden the mail server's been fixed. So as you can see, it's very robust, it's very clean, and very, very organized. We have this server that produces different server types for us, and we have all of the underlying algorithmic logic within these custom classes that implement some basic interface. But now we have a problem. We have a product owner that comes in and says, we've just ordered a bunch of these quantum processing servers that do a bunch of machine learning computation for us, and we need to make sure that we can resolve these immediately, right? Now, we haven't defined any of that here. We don't have to go into our core code, and we don't have to implement any machine learning servers. We just need to simply go into the server factory and say, okay, within our factory, we're going to start building machine learning servers. We're going to start building quantum processing servers. So we come in here, we'll say quantum, and we will return a new quantum server. Now, of course, we haven't built the quantum server yet, so in the server management package, I will go ahead and I will build a quantum server class. And in this class, I will implement the iServer interface. So now in this resolve method, we will simply say perform. So basically what we've done is we've taken some user story. We haven't changed our main code at all. right? Our main client code, it's going to look the exact same. But what we're saying is we're going to say that this main client tool can now handle quantum server resolution. So we go in here. Now we handle quantum. And let's go ahead and rebuild the tool. So now we come in here and we say we want to resolve quantum servers. And now all of a sudden we see that we can perform quantum processing resolution, and it goes through our print statements, and now the server is operational. So we've dynamically built at runtime a new server, and that's really this added benefit. We have a very loosely coupled application. And then of course, you know, if none of these things work, then we can just type in a fake server, and we'll just say invalid server type here. So that's pretty much it for the factory method. Just to kind of reiterate the pros, we're utilizing forms of abstraction and polymorphism. So we're kind of abstracting all this core client code away from the main app here, right? We just have this very simple, maybe this is a drop-down box from a GUI, and we can dynamically call the resolution algorithms regardless of the type, right? We don't have to manually specify the type of server that we want to resolve. So we don't have a bunch of case statements or if conditionals in the main portion of the app. We have a server factory that utilizes in interfaces to basically dynamically return a generic iServer object. Now, the generic iServer object is able to support all these different types of servers because they implement this interface. So we can return a mail server of type iServer because these respective servers implement the iServer interface. And these iServer interfaces force us to kind of bind this resolve function in each respective algorithm, kind of extracting all of this complicated logic and encapsulating it into these factory methods, these interfaces and things like that. So that's it today for the factory method. If you guys have any questions or would like to have me reiterate this in a different way, feel free to leave a comment or shoot me a message, and don't forget to subscribe. Thanks.